Section 6, Unit 1, Introduction to the Vertical Milling Machine. Milling machines feed flat or angled workpieces into a rotating cutting tool. Moving occurs in X negative, Y negative, and Z negative axis. Cartesian coordinate system. So over here you can see your quill vertical, so Z axis, your saddle transverse or cross feed, so you're going to be your Y axis, and your knee vertical is also going to be your Z axis, and then your table is longitudinal, so you'll be X axis. Base and column provides a heavy solid foundation for the mat, ties together all major machine components and the major parts of the typical vertical milling machine. So your knee, your clamps, and your clamping lever. The knee moves in Z-axis direction and supports saddle and table. Saddle moves in Y directions, your table moves in X direction. The adjustable micrometer collar of the knee elevating crank allows accurate movements of the knee. Your saddle movement, the A on the left, the saddle crank moves the saddle back and forth. Note the adjustable micrometer collar on the table or handle. And B on the right, after positioning the saddle, lock secures the saddle to prevent unwanted movement. Table movement, table crank handles move the table left to right. Note the adjustable micrometer collar on the handle. Turret allows machine head to be swiveled 360 degrees. Protractor positions and turret. Clamping bolts lock turret in position. The turret of the vertical milling machine can be rotated. Note the protractor of the clamping bolts. So your protractor here, your reference mark, and then your clamping bolts. The ram allows head to be moved forward and backwards, then locked in position. So your clamping bolts are here, and you're adjusting that there. The ram adjusts lever and clamping bolts. Alright, head. Contains mechanisms for holding, controlling, and driving cutting tools. Houses the spindle, precisely ground shaft used to rotate cutting tools. Houses the quill, telescopes in and out of the head to feed hole-making tools or positions cutting tools prior to movement in the X, Y, or Z axis. Can rotate 360 degrees to machine angular surfaces or to produce angled holes. The parts of a typical vertical milling machine head. So A is your high-low range switch. B is your variable speed dial. C is your spindle brake. D is your quill feed selector knob. E is your quill stop. F is your adjusting collar. G is feed reverse knob. So it's going to be right here at the very end. H is manual feed hand wheel. So that's going to be this big part here. I is feed control lever. So it's going to be right here. J is the quill. Going to be right there. K is the spindle. It's going to be the small part at the bottom. L is quill lock. So it's going to lock your quill from going up and down. M is your quill feed handle. So that's going to bring your whole quill up and down. N is your power feed transmission engagement crank. Right here. O is your high, neutral, low lever. So it's going to be on the side of the motor there. And P is speed change hand wheel. So it's going to be a little hand wheel right here to move it up and down in speed. The parts of a typical milling machine spindle, note the drawbar which tightens and the tool holding device. So you'll loosen this to drop the collet or whatever else may be in there. Your vertical mill high, neutral, low gear change lever. We just talked about that. The vertical mill variable speed control. A on the left, rotating the hand wheels changes the spindle RPM. And B on the right, which is shown in the window of the variable speed dial. So right now, if you're in low gear, you're going 240 RPM, where if you're in high, you're going about 21 120, somewhere around 2000 RPM. Alright, the milling machine spindle brake can be used to quickly stop the spindle rotation or to lock the spindle. The micrometer adjustment nut can be set so that the quill stop limits quill travel. Right there. The quill lock secures the quill in an extended position. The power feed transmission engages the quill power feed gear train mechanism. The quill feed selector knob is used to set the quill feed rate in inches per revolution. The feed reversing knob sets the direction of the quill feed. Pushing in sets downward feed, and pulling out sets upward feed. There is also a neutral position between the two settings. Pulling out the feed control lever begins power quill feed. Power quill feed will automatically disengage when the quill stop reaches the micrometer adjusting nut. The milling machine head can be tilted both right and left. After loosening 4 clamp bolts on the front of the head, it can be tilted by turning the adjusting screw. A protractor helps to obtain the desired setting. A. The head can also be tilted forward and back. B. After loosening 3 clamping bolts on the side of the ram, the head gets tilted by turning the adjusting screw. C. The protractor helps to obtain the desired setting. Optional features: a digital readout or DRO. It displays only actual machine movement, making positioning easier and more accurate. You ain't got to worry about backlash. Optional features again: a power feed unit attached to the table movement of a vertical mill. The power drawbar on a vertical milling machine allows fast mounting and removal of cutting tools by simply depressing in and out buttons. The power drawbar on a vertical milling machine allows fast mounting and removal of cutting tools by simply pressing in and out of buttons. This is actually a one-shot. I don't know why this is with this, but actually a one-shot. So pretty much you pull that down every 4 hours of operations, and then you fill with Welu. But anyway, so it pretty much greases the machine.